So it's been a great honor and pleasure to interact with such a senior engineers from all over the state of Tamil Nadu. It's been great, especially in these times where there's a pandemic around and we're all locked up in our house. It's always great to come out in form of virtual conferences and share our learnings, right? Basically, I would like to thank Arul Silvan sir, basically to introduce into this forum. And special thanks to INR sir, who is connecting me to this forum again via Arul Silvan sir. Our organization has been hiring graduates from Tyagarajar Polytechnic. So it's been a great honor to be associated with them and the type of work that they've been doing. So we have been fortunate enough to be connected with this set of people, right? So with this, I would like to share my screen. Let me briefly introduce myself. My name is Jayakumar Balasubramanian. I am a native of Erode. I studied my schooling there until I went to my engineering in Warangal. So that way, it's also equally pressure for me to come back and share my knowledge and learnings with senior people from my home state of Tamil Nadu. My organization is Emertxe Information Technologies. Basically, I'm one of the director. So I'd like to briefly introduce again. As sir said, I'm from computer science background. I graduated from NIT. It was called Regional Engineering College when we studied in Warangal, Telangana. After my schooling, I went there. After that, I went into the typical software development in the field of embedded systems. I started my career with a startup called Ishoni Networks, followed by Hewlett Packard, where I was involved in building inkjet printers, mainly the connectivity and networking firmware, all the networking software associated with that. After that, I went to Huawei. Huawei Technologies is a telecommunication major, as most of you know. These days, they're also in controversy due to the India-China, or the Make in India initiatives, right? So predominantly, Huawei is a telecommunication company. I was heading their embedded Linux group, where I was part of leading a set of R&D engineers to primarily take care of the embedded Linux distributions of Huawei's product lines. So primarily my area of expertise comes from the embedded software into various domains like consumer networking, printers, and telecommunication devices. So that's what I've been working for about 13 years. So in that 13 years of career with various corporates, I had an entire range of experience, starting from conceptualizing an idea to all the way taking into the market and making live deployments. And I played various roles in this my corporate career, being a technical leader, project program manager, and a group manager. So after about 12 and a half, 13 years with these various segments, I quit and I joined Emertxe. I'll talk about my entrepreneurial journey in my next slide. So I'm very passionate because I grew from a town background and I got my skill from a great institution like NIT. It's always when I look back, I believe that having the right skill plays a very important role. So that's where I taken it as a passion, and I quit my corporate career in 2014. And for the past 7 odd years, I've been instrumental in building my own organization, that is Emertxe. So I've been very passionate in terms of sharing my knowledge also. So wherever there is a forum to share, wherever there's a forum to learn, I'm open. That's when INR sir and Arun Silvan sir approached me. I didn't even think twice. I said yes, no, whatever it takes, let us go and do it, right? So in fact, the previous presentation by Mr. Srivatsan, I got so many things to learn because being from a computer science background, tend to miss the mechanical and water treatment aspect of it, right? So there is always some or the other learning wherever we go. So that's why I take it. It's not only about sharing my knowledge, and also to learn from others, people working in different domains, and also from senior personnel. So that's about myself. For my organization, as I told, we are an education company. Our primary role is in the skill building area. So primarily we train engineers who pass out of engineering colleges. As you know, in India, there are about 15 lakhs engineers pass out every year. Hardly minuscule of them have the employability skills. especially when it comes to higher end technologies like embedded systems, IoT, or full stack web development. So we take these people who finish their engineering and put them on hands-on practical training programs, and then we make them employable. And also, as you know, once people get into the job, they have various skill requirements. So we also train working professionals and organizations on a very customized and a specific skill set. So we train people anywhere from 2 years all the way up to 15, 20 years of experience. So that's what we have been doing as an organization. And as the diagram shows, you are building a pot using a hand, right? So basically, that's what our approach is all about, making things hands-on, making things practical, do mistakes, learn, improve. So that's been an approach we believe is the right way to learn. And that's what we try to inculcate in our learning programs as well. And these are all some of the statistics what we have done. We trained about 60,000 plus graduates so far. We done about 100 plus corporate training assignments. About 366 placement companies hire our trained graduates, name it semiconductor, name it telecom, name it startups, mid-sized organizations, research organizations. Pretty much everybody hires our trained engineers. And also we do a lot of customized training programs as well. Okay. So that's about myself and my organization. I hope I am audible, sir.
Yes.
Okay, all right. This is always sometimes challenging, in terms of good to know that. So let me proceed. So this particular topic, IoT, is being broadly debated, broadly discussed, and defining IoT is always been a challenge, right? So I would like to take the previous case. I was noting down a few points when Mr. Srivatsan was presenting about the water treatment plant, right? So basically, we talk about a traditional industry like water treatment plant, or it could be any sort of manufacturing plant. Okay. So we're all talking about digitization, right? How do we basically make the whole industry go digital? So when I say go digital, it's all about monitoring and predicting, and also taking some proactive measures. We spoke about basically temperature, pressure, humidity, filtering, so concentration, right? Mr. Stevenson covered a whole lot of topics, right? So what if we wanted to digitize the whole industry so that even we can, right? For example, when potentially a boiler will burst, right? What is the probability of it is bursting, right? So IoT is a technology which is going to sit in every digital, every traditional entity that we can think of, ranging from a door or a boiler or a water treatment equipment to anything that we can think of. For example, I was looking into a use case where somebody installed a IoT into a cigarette smoking box, right? So that it translates how many cigarettes an individual is smoking per day, right? So it can be as simple as that, or it can be as complex as what Mr. Sivatsan has presented in terms of water treatment plant. So considering that we are all from a broad engineering background, I don't want to get more detail into programming. That's why I also checked with Arul Silvan sir and INR sir about the target participants. So I'll keep it at a higher level so that we all can understand and relate and also apply to our professions, right? And of course, I'll be more than glad to answer the questions in the end, right? So what does this IoT architecture consist of, right? So the first piece that comes out is the IoT device, right? We spoke about the water treatment plant. Think about installing sensors and a very small device that sits in all these particular equipments that we can think of, right? So that's where the first piece comes into, which is typically a small device which has a sensor and a very minuscule programming done it at the end, right? So this basically takes care of the sensing or getting certain first level information about the device. For example, what is the current temperature inside the device, right? It starts with very elementary information about that. Then we can think of there are multiple such devices. I just saw the entire flow diagram that Mr. Sivatsan has shared, where you wanted to basically put them together so that you can have at least a centralized system where you can aggregate the data, right? Because so many equipments coming and pouring data from all over this equipment. So that's where we call it as an IoT gateway. So the IoT gateway basically integrates multiple IoT devices, and then basically it actually acts as a gateway so that it can further transmit that particular data to internet, right? So that's where your what you call the typical internet comes into picture. And then on the other side of internet, we have the cloud, where you talk about the IoT platform that sits into picture. And eventually those platforms will give you the applications or an interface which helps you to basically monitor the plant and also take certain predictive and corrective actions. For example, we see that in one particular boiler, the temperature is varying very much, right? So you'll get an indicator in the circle number 5 I mentioned, so that we can go back and take a corrective action. Again, that corrective action can be a manual action, or it could be an automated action also, right? So that's what it is all about. I see some of them as raising their hands. I will request sirs to wait so that we can take up that question. Okay, Srinivasan sir, I would request you to hold on. We'll definitely take questions in the end. So that's what we talk about IoT. We can apply any cases there, be it a street light management, or we talk about, as I was talking about, how many cigarettes somebody has smoked, or for example, how much of a sweet individual is concerned. For example, there is a diabetic patient, right? He would like to consume sweets, but he's consumed a little bit more, right? It can probably send an alert to wife saying that, no, this guy has consumed more sweet in his office, right? So it can be any case. The challenge, as I mentioned, right, it's very broad. Just move on to the second slide, right? This particular IoT has become like a conglomeration of any technology that we think about, right? For example, when you say IoT device, it has got a tons of technology associated with it, be programming, a microcontroller, which involves certain sensors, actuators, and you need to interface with any IoT gateway using a particular protocol like a Bluetooth or RS-232, or erstwhile industrial RS-485, etc., right? And so many protocols that comes into picture. So there is one piece which you call IoT device. Then when you move on to IoT gateway, which is relatively more powerful device, which actually monitors multiple IoT IoT gateway, which monitors multiple IoT devices, where you talk about much more powerful device which runs an OS, right? Typically, it could be a Linux or Android, or it could be anything, right? That's what you also call edge computing. I'll talk about it shortly. So that's the second piece which we talk about, IoT gateway. Then when you move on to the network, whole lot of things comes into picture. Today we talk about 5G networks getting deployed, right? So which need to be very lightweight, and we should be able to seamlessly send the data up and down via the network, where the quality of service also matters. What if, for example, there is a boiler temperature is rising in a very disproportionate manner, but it is not getting caught in the application, right? Basically, it will lead to a disaster, right? So quality of service, ensuring that there's a good internet connectivity matters a lot in Internet of Things, because if you take internet from IoT, it will remain things, right? It's of no use to us, right? And then subsequently moving on, we talk about cloud, okay? Where there are a whole lot of technology coming to picture today. Name any big player, for example, Amazon or IBM or Cisco. Okay, today they are not in cloud, they're not in business. It's as simple as that, right? Even if we talk about Zoom, we are doing this whole lot of video conferencing. It's basically delivered from cloud, right? We are sitting on all over the place and we are able to converse, right? So that's what plays a very quite essential role in IoT also. Which includes basically an IoT platform which exposes various web services. And think about, right, how much amount of data points that this cloud will be receiving, right? From a single plant, looking at the kind of equipment that we saw, there's a huge amount of data coming on a minute-to-minute basis or even a second-to-second basis, right? So basically, it has to be really a powerhouse, basically getting all those data and apply what we call business intelligence and analytics, right? So that it can be further represented in form of an application, right? Application is what, as a plant manager or an end user, or even for that matter, wife sitting at home and monitoring husband's, cigarette consumption or a sugar consumption, right? It's basically could be a web application, it could be a mobile application, or it could be any custom interface, right? Or an industry-grade device where you can have a panel which displays the whole information, right? So the point I'm trying to say is, right, this is a typical thing which I say in all my talks about IoT. It's my, I'm sure all of us would have heard about this particular story. about an elephant, right? There are 6 people, blind people, holding on to different parts of the elephant, and they describe the elephant in their own way. For example, the guy who is holding on to the basically leg, he says it looks like a tree, right? Whereas there is another person holding on to the trunk. So whom are holding on to a different part of the elephant, they describe elephant the way they like it, right? Or they see it, right? The reason being, elephant is so big, right? It's not, for example, a smaller animal like a cat where everybody can see, right? Elephant, all of them cannot be able to see, and especially when it comes to blind person, it becomes all the more challenging, right? So when I talk about IoT, the previous slide I shown, right? Just think about the sheer complexity of these technologies, right? Okay, it's like we can't even say elephant; it's like a giant, right? Right from you include mechanical engineering into it, chemical engineering into it. You involve programming. You involve a lot of electronics, right? So it's a conglomeration of cross-disciplinary engineering subjects that are coming together. That way, it makes all the more relevant to talk about this topic in an Institute of Engineer seminar, right? So because many of you I see coming from a traditional or a core engineering function like BHEL and many other public sector companies, right? So this is what digitization can do, right? Sitting in a control room or a centralized place, you will be able to predict, you will be able to analyze and take informed decisions, which is today done in a manual fashion, or we are doing it with a lot of experience, right? But if the data is represented in the right way, decisions can be done easier, and it can automate many things, right? So this is how I would like to basically put across IoT to the participants. Okay, so I would like to stop here and open my chat box. Whether am I making sense? Sir, is it fine? My pace and whatever explained so far.
So continue yourself. It's fine. Your audio and everything is fine.
Okay, sir. Yeah, thank you,
Okay.
I'll just move on. So now moving on, right? In this topic, right? I don't want to basically trends when I talk about what are the top 5 things that we should be looking at. Right? Again, it's not my top 5. Basically, looking into various trends, because there are also a lot of articles being published, top 100 trends, top 20 trends, and trends for 2020, etc. Right? This is my understanding. What I believe could be relevant for the audience, and based on my understanding about IoT. And my talk or my trends that I'm going to share in a very simple way, I'm going to more focus on the pieces 1, 2, and to some extent 3. Okay? Because as I told, there are a lot of technologies come together. I may not be able to talk a lot about cloud and applications, right? I'll mainly stick to device, gateway, and network. So that some of you who are working in the core industry will be also able to relate to what we talk about, right? It's more about electronics and embedded perspective. Okay. So the first point that I would like to talk about is what is called as edge computing, right? The trend that we are seeing is the edge is getting more powerful, and the edge is getting more prominent in the recent days. When I say edge, for example, the point number 2, right, where I mentioned multiple IoT devices are getting monitored or aggregated by IoT gateway, right? So this IoT gateway is a device which sits between the network and the basically the devices. So this edge is getting more powerful. So earlier, these devices, if you look at, right, there are reasonably powerful machines which primarily acts as a bridge between 1 and 3. That was how the initial IoT solutions were conceived, right? So this created some more issue, because if you are simply acting as a bridge between 1 and 3, basically this particular decision, which is supposed to be made at 2, it goes all the way up to 4, right? Which is cloud, right? And then subsequently, this particular information gets back to 2 and then to 1, right? So this was creating a lot of problem. So today, wherever you go and look into the latest thing about IoT conferences or even the technology trends, right? They say the power of computing earlier, it was only seen as 4, which is cloud. which is getting distributed between 2 and 4 nodes. So that's what we mean by edge computing or edge edge calculation in terms of IoT. So what does it mean, right? So edge computing basically distributes the load of data processing, because as I told, a lot of data that comes to the picture. I'll show you some example from the core industry which I recently came across, right? And because of this, instead of taking the decision at two, we don't need to go all the way up to cloud. It can be taken locally and it can be taken faster. Okay, and powerful edge devices are becoming more powerful. They're becoming more affordable. Right, as you know, one of the common trend, irrespective of whatever the industry that we are coming from, the computing is becoming faster and it is getting cheaper. Right, just think about our own laptops or PCs, right? Every 2 years, you see the price goes down, the feature goes better, the storage becomes better, the speed becomes better, right? So that way, by moving the computing power more into the edge devices, you can run what I call AI, right? What you call analytics or artificial intelligence, so that we can predict these things earlier, right? Rather than going to a cloud and analyzing, by analyzing in the edge itself, things can become better. So that's what we mean by edge computing, right? And cloud or centralized system makes this make the overall thing more stressed, because you also need to pay for your network bandwidth, which is again an expensive affair, rather than taking the decisions locally. Right? Compared to cloud, edge is cost effective, right? Because every time we are taking cloud service, they call it as what you call pay as you go, which you call platform as a service or software as a service. They keep charging more as you are consuming more bandwidth or any other resources in the server side. So that way cost can be optimized, right? So some of the things that edge computing can do is real-time data processing at the local level itself, and basic data visualization and analytics, at least some of the critical parameters, like for example, humidity is running too high, pressure is running too low, etc. Right? And some kind of a data caching and buffering can be done locally, so that the cloud can consume the data in a much more regulated manner. Right? So this is all we see one major trend. So let me repeat, going back to my previous slide. Instead of 4, things are getting shifted towards circle number 2, which is nothing but the edge. Then the second thing that we talk about coming further down is about devices, right? With device is actually the thing which interface with a non-digital entity, be it a boiler, be it a door, or be it any kind of industrial device that we can think of, or a consumer device that we can think of, right? So devices are getting smarter. So when we say smarter, what do we mean, right? Okay. So in the edge and cloud, we saw the resources are increasing. Okay. But in the device side, when you look at, things are getting smaller and smaller. So they're thinking with a relatively smaller size, right? One of the common debate that we get into is feature versus function. The form factor versus functionality, right? How smaller the device can become and how better it can give the functionality. For example, be it in form of our cell phones, right? You can see how the form is reducing, but functionality is increasing. Right? So the same thing applies to IoT devices also. So one of the key trend that we are seeing is how much smaller they can become and how much more functionality they can become. Right? So here, one of the key things that we talk about devices is power management. Right? Similarly, when I mentioned about edge computing, the network is basically the costly affair where you need to pay for the bandwidth. Similarly, when we spoke about devices, one of the key elements that comes into picture is how much amount of power they consume. I'm sure being experts in a mechanical industry and electrical industry or any other core industry, I'm sure controlling power or reducing the electricity usage is one of the key priority for any core engineer that we can think of today, right? So when it comes to smarter devices, they're thinking not only ensuring that, for example, when you are not operating particular device, can we manually switch off? So that was the original thinking. Now we are thinking of, can we switch off using software, right? So more power management using what we call software. So that is a trend that we are seeing. Other thing, whenever we talk about IoT, is that the topic of security, right? What if somebody breaks into the network and then steals all the data about your own industry or your own local information, which again becomes a wealth today. Today they say data is the new oil, right? Whomever is get the data, they become more powerful. Probably we see a traditional oil company like Reliance, they're getting a data company today because they know that's where the future is going to be. I'm sure all of us are watching about the investments that they've been raising in these challenging pandemic times. Okay? So security becomes a very natural and very integral part of anything that we can think of. Okay? So since IoT connects so many entities together, security plays a very critical role. For example, one of the statistics they say 100 million cyber attacks have happened only in the first half of 2019, right? And especially we know our own neighboring countries like China, where they pay and then they make people hack the network, right? Okay, today even to use Zoom, there was a concern about security. Sometime back, there was a lot of controversy. There are a lot of thing about should we use Zoom or not, right? Okay, so these things become integral part of IoT also. But when it comes to device which sits in the next to the leaf of the IoT solution, there are features like OTA. When I say OTA, it's over there upgrade, right? I found a security hole in a device which is sitting in my plant, which is 100 kilometers away from me. I cannot go back, pull out the device, and then I can replace the device, or I can do something, right? As you might have seen, right, our apps, right, mobile apps, and even the Android operating system, it keeps pushing on upgrades, right? Can we upgrade and then it becomes basically secure, right? So today there is a lot of push in the smaller IoT devices to be more secure by supporting features like over-there upgrade. So that anytime you feel there's a potential vulnerability, you can push an update, like how a Facebook app or any other Android app by pushing an update, so that the device gets automatically updated, which sits 100 kilometers from you in a small device in a plant, so that you maintain your network in a overall network in a very safe manner. So security is another consideration similar to the power management. Okay, and when I talk about power management, so power majorly consumed by the device, right, as we know, and one of the key element in power management is about how much information I can transfer by using as less power as possible. Okay? That's where we talk about Bluetooth in terms of mesh networking, where multiple devices in the industry can be connected using a mesh, and they transfer the data to the edge or IoT device by using as less electricity as possible, and more efficient possible. So this is again going back to the second point of power management. And as you know, more devices are coming in, more protocols are getting invented these days, right? You talk about ultra wideband, we talk about USB 3.0, right? And we talk about gigabit Ethernet. So more and more networking and connectivity technologies are coming up. And even when you talk about security, we can even talk about things like blockchain, etc. So how do we basically, make them work together? So that's where multiple peripherals and interfacing also plays a very important role, right? So I spoke about two trends. One was in the IoT gateway or in the edge computing. Then we came one level down and we saw the end device, what are the important aspects in terms of power, security, efficiency, etc. So that's the second trend we are seeing across all the industries. Okay. And third one, when you talk about the devices, as I told, they're getting smaller and smarter. There is also a huge push from all the big companies that we can think of to introduce a very lightweight OS. Right? When you talk about a mobile phone today, majority of them run Android, and some of them run iOS. Right? But Android can run in a very rich interface today. As you know, our phones are getting more powerful. They're getting more multi-core processors, and my RAM consumption is going high, and even the storage is going high. Okay? But as I mentioned in my previous trend, right, in terms of devices, they're getting smaller and smaller, right? Where they're trying to see how can I cut the resources so that I can do as many things as I want by making as little investment as I can. So that's where, in a very tiny device, can I run an operating systems? For example, Android, right? All of us are familiar like that. Android from Google has released a operating system which is specifically tuned for small IoT devices, which they call Android Things, right? And we talk about FreeRTOS, which is another open source based RTOS which has been remaining for a long period of time. Now basically Amazon come and basically acquire that particular company, because they know even big player like Google or Amazon, if they cannot support devices, their IoT solutions will be of no use. As we saw, all the 5 pieces has to work together to give an end-to-end IoT experience. The similar lines, we have another new operating systems like Mongoose OS or ARM embedded, which are coming into picture. So which you can call it as, what do you call the new embedded OS. It is not, because they cannot run traditional Linux or any other operating systems because the resources are very small. I'm talking about, for example, a device with 8 MB of RAM and probably about 25 or 30 MB of storage, right? How can I run an operating system in that, in a small device which sits in my industry, right? So this is a Things OS. Almost all the major players that we can think of, right, be it Google or Amazon, they're heavily investing in this side also. That's the third trend. It makes the development faster, of course, but they give a lot of interfaces. And finally, I talk about the the software or the when I talk about the edge computing, it's of no use if there is not enough power to support from the hardware. The software cannot exist alone without the hardware. So that's where we have this particular hardware. Today, if you look at any major players, they can basically think about pushing more and more powerful hardware. Okay, for example, if you think about a company like Nvidia, right? I'm sure all of us would have heard this company, or if not, for example, we've been using graphics card in our laptops. Right? They started as a graphic processing unit company, right? And then they went into something called the accelerated GPU, and then today they talk about TPU, which is nothing but a TensorFlow processing unit, right? So what I'm telling is, as the data is getting more and more, there is absolutely more need for the hardware to become powerful. Okay? There is one use case mentioned in point number 2. For example, recently I was in conversation where I understand an industrial frying device, which basically manufactures chips, right? In order to measure and predict that particular machine's performance and maintainability, 87 lakhs data points have been collected. Now imagine you need to process 87 lakhs data points and come up with a model to basically analyze and predict how this device will look like, or when it would require maintenance, etc. in the future. Okay? We cannot run it in a normal hardware. Basically it will take forever to basically process these things. So that's where more powerful edge computing devices. So one example I shown here, we talk about the Jetson NVIDIA, which is a kind of a hardware which is custom designed for basically doing more powerful edge computing. Okay, in fact, traditional companies like NVIDIA, or even for that matter Intel, they're reinventing. Okay, earlier they saw the PC revolution, then they saw the mobile phone revolution. Now they're custom manufacturing chipsets and even platforms like what I shown, mainly to ensure and support the large scale data requirements of IoT. Okay? And we cannot just imagine how much amount of data that is getting processed across all the entities, right? Things like parallel computing, and that too, doing that parallel computing in a distributed internet fashion, etc., are going to become more and more relevant as we move forward. And another interesting thing about IoT is that it is not necessary that you are transmitting data only in text format. Okay? We talk about video, and we talk about image-based, processing. I'm sure all of us are listening to a lot of new solutions that are getting invented due to COVID-19, etc. But we talk about face recognition, right? And imagine you need to recognize millions of faces, and you need to send to centralized entity and then get back, right? Think about the amount of image processing capability the hardware should have. Okay? So that's where the hardware is getting more powerful, especially in the edge side, which is going back to the trend number 1 I spoke about, right? So it's getting more power in form of these type of processing entities, right? Okay. And last one, I cannot stop but talk about the skills point of view. I see a lot of academicians, a lot of people involved in some or other form of skill building, right? Okay, is about JavaScript. Okay? So earlier, when I say the programming or designing perspective, traditionally all these embedded systems, be it the IoT device or a edge computing device that we spoke about, they've been primarily programmed using languages like C or C++, or even in some cases, if you look at relatively older devices, they might have been even programmed using assembly languages, right? Okay, so that's what is been traditionally. It was used mainly because, as I told, the device expects things to be smaller and smarter. So your source code or the software size need to be smaller. That's where C C++ act as a middle level language, and it's supported. Okay, but what is I am seeing is that that particular trend is also changing, where JavaScript is getting more prominent. People who mean involved, I'm sure all of you would have heard about JavaScript. JavaScript was initially used as a website programming language, or a scripting language that runs in a browser. But today, that has been predominantly getting used to program IoT devices and gateways. Okay? For example, there is a variant of JavaScript called Salem, which is traditionally being used in web programming. It is getting transitioned into areas like artificial intelligence, robotics, IoT device programming, etc., so that things can become easier. Right today, if you look at our own next generation of people, today at the age of 15 and 16, people are learning Python, okay, instead of learning C and C++. Right. So basically, by learning this JavaScript language, which will definitely make a lot of value to an engineer, but also helps to basically leverage and program the embedded systems, and when it comes to the IoT perspective. Okay? So if you're looking forward to learn something in this pandemic times or something, I'm sure you should definitely give a shot at JavaScript. Okay? So that's what is that trend. Okay. The fifth trend. So let me summarize. First one was edge computing, where the computation power is shifting more towards the edge from the cloud. Second one was devices are getting smaller and smarter with more efficient power handling, more easier way of peripheral interfacing, etc. And then third, we spoke about basically the Things OS, where big companies are investing and making operating systems for tiny devices, and nothing is possible without a very powerful hardware. That's where big companies like NVIDIA making a customized hardware what is shown. And finally, from a skill building perspective, or from a programming perspective, or a learning perspective, JavaScript is going to basically play a very certain and a very prominent role as we move forward. Okay. So that's all I want to share. I think I would like to thank again. So these are my coordinates. My email ID is mentioned there, and I'm based out of Bangalore. And these are all some of our social media links. You can take whatever, note down any kind of discussions, offline, collaborations is most welcome. With this note, I would like to thank you for giving me this opportunity to share, and I would like to take up any questions that our participants may have. Thank you very much.
Thank you, Jayakumar Balasubramanian.
Yeah.
Before going for the question answer session,
yes, sir.
I'd like to invite Sajan Singh Yadav, who is chairman of Rajasthan State Center. Sajan is online. Okay, sir. We will move on to the question answer session. End of that, I'll invite. So, anybody have any questions? Just you unmute yourself and then you ask a question.
Hello, sir.
Yes, sir.
Yes, sir.
Sir, any IoT device developed for checking the human body parameters, sir? Economy, for checking the temperature, pressure, blood flow, no, in each point.
Yeah, quite a lot of things are there, sir. When it comes to the personal health area, there are a lot of devices are there. In fact, there are devices which are even available to even monitor the pets. Right? I even come across a device which monitors body temperature, etc. for a dog. There is a startup working in Bangalore. Right? Yeah, of course, for human beings, things are available, sir.
Thank you, sir.
Welcome, sir.
Yes, sir. Sir, good evening, sir. Yes, sir. So, you can hearing me, my voice?
Yes.
My question is the small things, sir. So now the society is going to change the IoT, Internet of Things, RPA, and some other things. So is it going to affect the employability of the poor study people, sir? So because I think it's a lagging of the employment ratio, I think, sir. That's what I am trying to ask.
So it's I don't see anything that is coming down, sir. It is actually going to become better. What I see, especially if you look at IoT as a domain, this particular pandemic has forced companies to innovate in a new areas. For example, some of the cases that I recently came across was we talk about social distancing, right? Okay, so how do we basically ensure social distancing effectively happens? Of course, we have Arogya Setu app, etc., but they're not foolproof, right? Countries like Israel are already thinking of embedding a chip in a human inside human beings, so they can't take out, because here we don't use Arogya Setu app. We can switch off and be happily, say, I'm following social distancing. In the similar lines, you talk about basically the personal protective equipments, right? Today we are having a lot of challenges in form of allowing whether the virus is entering or not. Medicos are facing a lot of challenges. So there are certain companies which have specifically started innovating post-pandemic era. But I see that the employability is concerned, at least due to IoT. I see it is only going to go up because it's not an area where they can just hire or fire people, or they can do a very low-end kind of software development, which is what probably we tend to hear. Right? A lot of people, you can see big companies are laying off people, etc. So I don't see that is happening for such industry because it requires a lot of deep technical expertise, and the solutions are really going to make a difference. So I'm already seeing, in the last 1.5 months, since I also work on the employability aspect, that I answered. The last 1.5 months, at least from June, July, almost 2 months, I see the hiring trends again picked up. Okay, at least these domains are concerned, right? So I see it's only going to act positively going forward.
Thank you so much, sir. Have a nice day.
Sir, Jayakumar sir.
Yes, sir.
Good evening. Another question.
Yes, sir.
In the early stages, students learned this C++, and Java.
Correct,
In between, they have gone for other languages. Now it is picking up, sir, again. The JavaScript and C++. In the
Sir,
IoT.
yes, sir. It is always been there. So I'm not telling that C++ is not there. C++ is still used in areas like traditional embedded systems, right? But if you look at JavaScript, it is getting more popular due to IoT. That's what my slide was. So definitely, see, the problem is not whether it is C or C++ or JavaScript. It's about how well they know the subject, sir. It's like I always tell as an example, just buying a treadmill, I will not lose weight, right? I need to daily run in that, right? Or I buy the dumbbells, my health is not going to get better. I need to exercise. The same way, programming languages, I would say any engineer today, they wanted to have a good career, they can learn any language. I'm not telling whether it's a C++ or JavaScript. Very well, sir. That's a problem. Our people don't go in depth. They say, okay, I know something there, something here, right? Somehow I will scrape through my academia, right? I'm not against academia here. Okay, I know a lot of professors also joined here. Okay, but somehow they scrape through, but they don't go in depth and do certain things in a practical, hands-on way. Okay? So that's where the difference are. From that perspective, I would ask me any language, be it C, C++, Java, JavaScript, any language. One language, if they know very well, companies are ready to hire, sir. Okay, they can be from any domain, but they're struggling to hire because they know something about everything. Right? I know something here, something I did some course here, I did some certification here. But can you really solve a problem? Right? It's like saying I've done a swimming certification. Can you get into the water? No. I only So that's where it is heading to. But as long as they solve the problem, definitely there are a lot of opportunities, sir, in terms of C or C++ or JavaScript.
Good evening, sir. My name is Mohan.
Sorry, sir.
I have one final question. If chairman allows me, I will put it up.
Yes.
Yeah. Sir, it's a beautiful presentation. It's more oriented towards the, programming, computers, systems, all those things.
Right, sir.
My question is here. This IoT, it takes over the instrumentation profile from the industry, and moreover, now it's very difficult to differentiate control systems and instrumentation engineers from this, system software professionals. And see, in your presentation, IoT hardware, the smart devices, all those things you have explained in the level 1.
Yes, sir.
See, there are, nowadays, the system engineer, software engineers picking up the instrumentation and control system engineers job in the industry. Particularly, I'm talking about the, heavy industries like power plants, oil and gas plants, refineries,
Yes,
all those things.
Yes, sir.
And now it's, most of the industries are becoming more, automated, and more systems and networks, programmings have come inside.
True.
So it's very difficult to differentiate the role of instrument control system engineers job and software engineers job. My main concern now, the software engineers picking the control system engineers job. So how, do you feel the software engineers will understand the instrumentation and control system things?
Okay, fantastic question, sir. I would like to really thank you for bringing this question, because often, as one of the thing I already mentioned, if you see, IoT is so big and we are all seeing it in our own way, the elephant kind of picture, right? Okay. So today, what is happening, right? In fact, the instrumentation or control or anybody who is from the core industry, them picking up any form of digitization skill. For example, I come from the other side, right? I come from a pure computer science background, and I saw a presentation by Mr. Sivatsan, right? All these terminologies were Greek and Latin to me. Probably I studied in my 12th standard or some basic knowledge in my engineering, right? Pretty much I couldn't understand any terminologies. The reason being, I come from a pure programming background. So on the other hand, if you take a traditional instrumentation engineer or control engineer, they have much more solid core industry knowledge about their workflows, about how this various equipment works, etc. So in my opinion, it's going to be reverse. I would say, given a choice between picking up a computer science engineer to do a IoT job, or a core engineer or a control engineer to pick up IoT job, I'll any day hire an instrumentation and control engineer, because he comes from a core engineering background, and software can be trained. Software cannot be, software can be learned faster, unlike a core industry, which takes years to build an expertise, right? So from my perspective, how I see is that it's up to the traditional or whatever heavy industry instrumentation and control engineers to see IoT as an opportunity and leap forward in their career by obtaining these digital skills. That will take them places, sir, because a combination of core industry knowledge with the programming software system knowledge will basically make people really, really valuable. In fact, we even hear from big companies like Tata Steel, they want to completely transform their steel production using this IoT, right? So there are a lot of career opportunities open up for such engineers. Whereas on the contrary, a pure computer science engineer coming up and taking an instrumentation control job, it's going to be very difficult, sir. Because, for example, I told about myself, right? I don't understand any vocabulary that Mr. Sivatsan spoke about, because I don't have any idea, right? So I would see the reverse trend. I see it's an opportunity for traditional engineers, even mechanical engineers. Right? I know my own very close people in my own relative who is transitioning from a traditional hands-on mechanical two-wheeler R&D engineer to a data science engineer, because he knows these parts, how they work. Him becoming as successful as a data scientist is more than reverse. I hope this clarifies, sir.
Really, I'm very much thankful, sir. First time I'm hearing a computer science guy accepting the truth and openly telling this one. In many, I have interacted with many software professionals, when they come into the heavy industries and working as a system engineers, they never accept this truth. But really, I'm thankful to you that you have accepted. Control system and instrument engineers definitely will understand every pieces of equipments in the industry, and if an opportunity given to them to learn the programming, to work as a system engineers, they will do better than the computer science engineers.
Exactly.
Thank you very much.
Sir,
Exactly.
Yeah.
That's what you cannot differentiate between instrumentation and computer science. They have to go together. Unless otherwise, this the coming years, instrumentation, computer science, and IoT are going to have a single track, and it is going to be unique.
Precisely,
sir.
Precisely.
You cannot differentiate between instrumentation and the computer control system.
Right.
I consider in many other fields, they go together. They go together. Even Reliance, I can find number of people in instrumentation are doing the control system work and instrumentation work. Right. So the future of the year is going to be a mix. Multitask persons are required. So you cannot say that I know only instrumentation, I know only control system, and you should not have compartmentalized field of work. You have to go together. In the field of IoT, it is a good opportunity for everybody. Yes. Don't ask which instrument is there in IoT. In every field of life, IoT is there. In case, and I'll make one small example of healthcare system. Mm-hmm. In healthcare system, everybody is having diabetic. Yes. Diabetic, nowadays, they have given a small wrapping like a small device in the hand, and which has a sensor, which has an actuator, and has a processor. Yes. Actuator senses the blood level, insulin level of each person, and communicates to the processor, and the processor gives to the information to the host computer. And immediately the host computer gives an instruction saying that this fellow is highly diabetic or the insulin level is poor and he has to be insulin given. Then immediately a signal is going and the actuator gives a pin prick and the insulin is pumped in. And insulin is pumped in. And that is done nowadays for every 1 hour or every 6 hours, depending upon the diabetic case. And it is a system of IoT. The system of system wherein your data, your health data is recorded somewhere else. And it is being monitored and you are given a proper treatment. This is field of our life. So in future, don't say that IoT where I am going to use. You have to find an application. Each field of if I am a civil engineer, if I am an electronic engineer or a chemical engineer, I have to find an application of these things for making IoT. Then only you can sustain in future years. Otherwise, you will be in Stone Age only. You will be definitely you will be in Stone Age. So it's a good eye opener, and it should be applied in every field of life. That's what people like you can give some tutorial classes like things to our college students and see that it is brought to the limelight and people are knowing it. Thank you.
Sure, sir. Sure. So a couple of things I want to add before I close. I'm sure I'm taking more time. See, we spoke about the instrumentation control engineers and stuff like that, right? So typically, if you look at it, because we worked on some solutions, traditional PLC, SCADA, or any kind of monitoring, it's not new, right? It's been there probably for 30 odd years. People doing a plant monitoring is nothing new. All we are doing is we are adding a software layer on top of it so things can become easier, right? Here I would like to say engineering part 1 and part 2. There's nothing new that we are going to invent. So that's one. So that way an instrumentation control engineer or electrical or electronic engineer making more transition into the IoT side becomes easier. One. Second point, coming to talk about the computer science people, right? This is my own opinion. Somebody may have other opinion, right? Somehow, okay, this is my opinion because I worked with multiple diversified technologies and background. Somehow we overblown these software engineers out of proportions. Just because the industry came 20-30 years back, they're getting 6-digit salaries compared to a core engineer. We somehow started over-emphasizing and giving over-importance to software engineers. I'm not discrediting computer science. I'm from that background. That's the thing.
2K problem.
It's a societal problem, because if you go and look in the West, right? If you go and look in Europe, or if you go and look in US, they don't differentiate. I'm an engineer, whether I'm a mechanical or I'm a civil or I'm a computer science, I'm an engineer. I'm supposed to do the job that I'm going to do. Only in our society, we are overblown the software. A civil engineer becomes software engineer. Mechanical engineering becomes software engineer. So we only mix it up. And suddenly now, all of a sudden, when companies are laying off, we are trying to understand, why they are getting laid off. Okay, so that's the whole thing. So thank you very much, sir. Any other questions? Unless I'm running out of time, I think it's already 10:50.
Okay, I have one question to Jayakumar, sir.
Yes, sir.
You mentioned about protocols, right? For
Yes,
device side as well as for interface. So
Yes,
these
sir.
protocols, RS-485, IP or MVB,
Yes, sir.
based on what they are chosen, is it purely based on the bandwidth, or how they are chosen?
So it's a combination of many things, sir. As I told, one is the range, right? Like what is the distance that I'd like to communicate? Another is the power consumption, how much amount of electricity is going to consume. Third one, how much overall the cost that is coming out to be. For example, in some places, there may not be possible to even run wires or cables, right? Traditionally, we used to run 485. It may not be possible with this new age devices, that they may not even have an interface to do that, right? So in such scenarios, they take a combined approach of power management and the cost effectiveness, the range, and even for that matter, if you are going to utilize the battery, right? Like how cost effective it is to use the battery. So it's a combination of decisions that are used to take a decision with respect to the protocols to be used between the device and the edge or the IoT device, right? Sorry, IoT gateway. That is the challenge. But between the IoT gateway and the cloud, pretty much things are standard. I use pretty much have a HTTP, which you use for a browser. Again, they have a lightweight of it we call MQTT or COAP. Those protocols are pretty much standard, lightweight. There is no confusion there. Okay, either 1 or 2 or 3. That's all. But here, when it comes to device to gateway, there are a lot of protocols available, because many industries are from the traditional background. So that's where the consideration of these parameters, because sometimes we even need to replace the equipment, which will become more expensive than implementing IoT. So that's where companies are taking combining multiple parameters, they are taking a decision, sir.
Okay, thank you.
Yes, sir.
Ramdas sir.
Yes. Yeah.
Ramdas sir, shall we come?
Thank you, Mr. Jayakumar, sir, given the excellent presentation today.
Yes.
And then I thank Srivasthan also. We have tomorrow Tuticorin and Tirunelveli local center doing that, going to do that technical program. Tirunelveli, they are going to talk about cyber security, and then cyber security by Mr. Vijay Krishna. And then Tanjavur local center, they have engineering application in food safety and security. Mr. Anand Kumar, Dr. S. Anand Kumar going to take our tomorrow session. With this, I think I thank the Salem local center chairman and the Ranipet local center chairman to arrange excellent 2 programs. Thanks one and all. Now, Narayan Swami will take over as a formal vote of thanks.
Thank you, sir. Good evening, sir. Good evening to everyone. Respected engineers, Rajagopal, Chairman, Mari Local Center, sir. Respected Engineer Ramdas, Chairman, Tamil Nadu State Center. Respected Dr. Rajavani, Council Member, Mari Local Center. And Engineer Gangian, sir, Chairman, Ranipet Local Center. Engineer Salem, Honorary Secretary, Ranipet Local Center. Engineer Sajay Yadav, sir, Rajasthan Chairman, State Center. Dr. Rangareddy, sir. Engineer Kothari, sir. Dr. Rameshwar, sir. Dr. Ranganath, sir. Respect Chairman Arul, sir. Dr. Chelvan, Salem Local Center. Honorary Secretary S. Logadan, the Salem Local Center. And our 2 speakers, Mr. Engineer S. Srivasthan, Manager, Water System, Well, Ranipet. And Mr. Jayakumar Balasubramanian, Emertxe Information Technologies, Bangalore. Both I have given the very nice lecture meetings. One from water plant system in BHL, as well as in IoT things. 5 things he has given. In water systems, he has given the why the water treatment is required in the Bell thermal plant and the water requirement. Everything he has given very nicely, and whatever the questions has been asked, he has given the clear-cut answer for that also. As well as our lecturer, Jayakumar Balasubramanian, he has given the IoT things. 5 things he has given on that. First of all, he has given the architecture of IoT, and he has given 5 points: edge computing, smart devices, things OS, and powerful hardware, as well as the JavaScript. And whatever the questions asked by our viewers, he has answered well and in satisfied level also. So, respected all the viewers on this web meeting. As Honorary Secretary of Madurai Local Center, I thank to everyone who has participated on this web meeting, as well as our chairman, Tamil Nadu State Center, Ramdas, has given tomorrow's program. Tirunelveli as well as Tanjavur, they have given the program. So tomorrow also join for that. Thank you very much. Once of all, again, I thank to everyone. Thank you, sir.